Okay, what about moment of inertia? This idea that you can apply, let's see, moment of inertia, that you can apply some torque and how much angular acceleration you get out of it is that ratio is the moment of inertia, sort of like the role that mass plays in linear kinematics. So let's take our example of a rod with two masses on it, like little m and big M, and we want to know what's the moment of inertia of this rod, say spun around an axis through the middle. So that means we need to know exactly where these things are, and let's say they're at the ends of a rod that has length L. And we're going to rotate it around the middle. So in this case, then, the moment of inertia is going to be simply the sum of each little piece of mass times how far away it is from the center of rotation squared. So let's do that now. So this will be little m times half of L squared plus big M times half of L squared. Which means we're going to have 1/4 of little m plus big M times L squared. And that's the answer. Okay, so the other thing you should notice when thinking about moment of inertia is that it very much depends on the axis around which you're rotating something. So if we do this problem again, but instead of rotating around the middle, so little m and big M, if we do this problem again now rotating around the one end, you're going to have a different moment of inertia. So let's try it. Now the little m is at 0 and big M is the full distance L away from the center. So now our moment of inertia is big M L squared. So you should think about how that compares to the answer we got previously, right? Okay, so let's see. How about the rod? Well, for the rod, now what we have to do is add up little pieces of the rod. So let's try that. And if you have a rod here like this and you're going to rotate it, let's say, around one end, like this, what you're going to do is have these little pieces of mass. So let's say the rod has a mass of m of the rod this time, plus the length of the rod. So now the moment of inertia is written as the sum of r squared dm. And so if we measure distance from the center of rotation, and after all, that's what we mean by r. Don't forget, this isn't a radius. This is the distance away from the axis of rotation. If we remember that, then we'll have each little piece of m will be at some distance x squared, and the little piece of m is the density m over L times the little piece of length. Okay, so this turns out to be, let's see, the m over the L out in front, and then 1/3 x cubed from x equals 0 to x equals L, which is 1/3 m over L squared. So we have a different number now. And notice that this is only around one end. You should be able to do this again and show that it's 1/12 m L squared around the middle.